Functions are a way of relating values to each other. Specifically, for each input, we should have exactly one unique output. So a common metaphor used is like a machine where we have some input going in. There's a function of the machine that translates it to an output. So our input number is X, and then our output number is Y, or what we'll be using interchangeably with Y is this notation f of x. So where you can see this description of y equals 2x plus 3 here, what we could do is say f of x equals 2x plus 3. So with this function notation, what we see is our function, which we can use different letters for. Most common is f. I read this as f of x equals 2x plus 3. And what it's doing is it's giving me a form for if I have this input x, how is x going to be treated? And that's where we see this 2x plus 3. In that really this function, how it's behaving is that it will take whatever the input is, multiply it by 2, and then add on 3. In this case, our input is 4, so that's where we get 8 plus 3 gives us an output of 11. So our function lets us input different values, and then we should get just one value out, in that I can't choose a number for x and get multiple values out. It's going to be one number in, one number out. So for the notation, we see that y equals f of x, and that's how we read it. Sometimes a common mistake is thinking that this is f times x, but this notation is f, and then the parentheses are representing of, and then x is showing us what our input is. X is our independent variable, so often how we use our functions is we choose different values for x. We say what happens when x is 5, what happens when x is -2. So it's independent in terms of what we choose, and then y is called the dependent variable because it's going to depend on what we choose for x. So like the machine up above, x equals 4 was kind of this independent choice. We just chose it, it goes in, and then getting y equals 11 out depends on what we started with. In this case, the fact that we plugged in 4. Another thing we'll talk about is average rate of change. It's thinking about how does this function change over time on average. Or time is kind of the common application within word problems. It's really as we go across the x-axis. So if we look at how our function changes from x equals a to x equals b, what we'll look at is the difference in the outputs over the difference in the inputs. Okay, so let's look at some examples with this function notation and evaluating. So here we have this function g. So g of x equals 3x plus 1. And we want to find g of 4. So the value that's being described inside here is describing the input to our function. It's describing our value for x. And this 3x plus 1 is giving us this form to follow. In fact, something I like to do is take what they give us, and wherever I see my variable x, I'm going to throw in parentheses plus 1. Because it's telling us no matter what the input is, we want to multiply it by 3 and then add 1 on. In this case, we're plugging in 4 for where x is. And then we just simplify. 12 plus 1 equals 13. So we end up with g of 4 equals 13. What we also get out of this is a coordinate for this function. We can now see what happens if x equals 4, then with this function g, y equals 13. So that's telling us about this coordinate for 13 for this function 3x plus 1. Another example here, say we wanted to find f of -1. And I like to just rewrite this form, so -2x squared, but instead of x, I'm just going to put parentheses, minus 5. So that's our form for the function, and I want to input -1 for x, so I'm going to put that in the parentheses, and then simplify. So negative 2 times negative 1 squared is a positive 1, minus 5. So this is negative 2 minus 5, which is negative 7. So f of negative 1 is equal to negative 7. Or if you wanted to translate this into a coordinate, x is negative 1, y is negative 7. So with this function notations, you have two pieces. What's inside the parentheses when you have f of, inside is your input, and on the other side of the equation, what f is actually equal to is the output of the function. Okay, let's look at this average rate of change. So we're looking from x equals negative 2 to x equals positive 3. So what we need to do is find the function output for each of these because we're trying to fit this form f of b minus f of a over b minus a. It's just we're going to swap out those letters for numbers. Order doesn't matter as long as it's consistent kind of vertically. So let's say I put 3 there. So if I'm looking for f of 3 first, then I want to have 3 first in the denominator. And then f of negative 2, and then I'll put negative 2 as the second piece in the denominator. So let's find f of 3. So our function, oh sorry, this is going to be using h, but same idea. I'll just change those to h's and it all works out. All right. So h of 3, I'm taking 4x squared minus 3, and I'm going to plug in 3 there. So that's 4 times 9 minus 3, which is 36 minus 3, which is 33. So h of 3 is going to be equal to 33. I need to find h of negative 2. So I'm going to do 4 times negative 2 squared minus 3, which is 4 times 4 minus 3, so 16 minus 3, which is 13. So now if I'm trying to fit this h of 3 minus h of negative 2 over 3 minus negative 2, well, h of 3 we found is the number 33. So what I've done is I've replaced this whole notation h of 3 by just the number 33 because we found out those were equal to each other. And then we'll have subtraction. And then where I have h of negative 2, I'm going to replace that with the numerical value of 13. Over 3 minus negative 2, so 3 plus 2. And then I just calculate 20 over 5. So the average rate of change is 4. It's telling us how our outputs changed over on average across these x values. We'll look at some word problems that can get into more context of what this average rate of change looks like. But that's some basics of our function notation and how to plug in and calculate.